Okay, this is Algebra 1, section 7.3, rational exponents, page 410. Okay, so we talked a little bit about this yesterday, but I'm going to just kind of assume that you don't know what we talked about. But we know that this is a radical of b, correct? Mm-hmm. And this means the square root of b. This means that some number times itself equals b, correct? What we learned yesterday was that this is the same as this, b to the 1/2 power. Because I'll show you why this works. We know that if I take b to the 1/2 power and I times it times b to the 1/2 power, you might have forgotten this, but this is b to the 1/2 plus 1/2. Now it's really hard for my marker to make that, which is b to the 1 power, because they have the same denominator, and we add the numerators. Correct? So therefore, the square root of b and b to the 1/2 power are the same. Does that make sense? And in fact, if we have any radical that has an index, and I don't remember what this book uses. I'm looking real quick. I think it's to the index of n, that this is b to the 1/n power. Okay? And I'll just get this out of the way, but if I have, this is m, and this is b to the n power, then this is b to the n/m power. So the numerator is what it's to the power of, and the denominator is all the root. We talked a little bit about this yesterday. So if the directions say to simplify, okay, and I have number 1, if I have 25 to the 1/2 power, okay, that is what? What is 25 to the 1/2 power? 5, correct? Okay, that is correct. Now some numbers, in the first it says write an expression in radical form or write it in exponential form. Okay, so I'm going to put write in radical form or exponential form. Okay? I didn't say simplify. I'm not simplifying anymore, okay? I'm not simplifying. Okay, number 2. If I have the square root of 18, what form is that in, Tirsa? The square root of 18. Is it in radical form or exponential form? It is radical form. So let's change it to exponential form. It would be what? 18 to the 1/2 power. Very good. Very good. All right. Now let's take a look at this one. 5. Now be careful on this one. 5x to the 1/2 power. What form is that, Jackson?
That is exponential.
Exponential. So we want to put it in radical form, Tater. Right? Be careful on this one. Yes.
Would it be the radical and then 5x under it?
Okay, that's what you would think, right? Tell me, this exponent goes to the x. Does it go to the 5? No.
So 5 is the index, right?
No, the 5 is out front. And it looks like that. So it's 5 times the square root of x. How would I get both of them under there? How?
They're both
Parentheses. 5x to the 1/2 is the square root of 5x. Do you see the difference? Okay, you got to be careful on that, because the old author will do that to you, correct? All right, so let's do one more. What if I have 2 times the square root of x? What form is that? Radical. And how do I put it in exponential? 2x to the 1/2 power. Is it in parentheses? No, because the 2 is not involved. Do we understand that? Okay, So let's talk about what happens when let's go back to simplification. All right, simplify. But let's change our root. Okay, instead of having a square root, let's do something else. All right, let's do the first one, a cubed root of 27. That's a 3 if you can't read it. The cubed root of 27. I don't know if I can do it any better with this marker. Okay, what number times itself 3 times is 27? 3. Okay, we talked about that. What would this one be? This would be the 4th root of 10,000. What times itself 4 times is 10,000? It would be 10. 10 times 10 times 10 times 10 is 10,000. And a quick way of doing this is just counting the zeros. So this would be the 4th root, there's 4 zeros, 10. Okay? All right, let's try one more. What is the cubed root? That's 3 of 64. Now Ryan says 4. 4 times 4 is 16 times 4 is 64. Now, what is the most common roots that we use? Cubed and square. Square root and cubed root. And the reason is because you got to have pretty big numbers, right? And then it gets confusing. Okay? All right. Any questions about that? All right. So let's keep with the simplifying. I'm going to go up here. I'll go ahead and write directions. Again, is simplify. But let's change this to a little bit to exponential. What is 125 to the 1/3 power? Okay, what that means is the cubed root of 125, right? What number times itself 3 times is 125 actually? 5. Does everybody understand that? 5 times 5 is 25, times 5 is 125, okay? Now, I'm going to give you a little tougher one.
If we want, can we write the radical by the exponential? And
In radical form, if it says simplify, yes. You can change it to the radical form. That's a great question. You can change it to a radical form and then find your answer. Okay, Jackson, you got 256 to the 1/4 power. Okay, that means as what Braxton just said is this is really the 4th root of 256. This is what it means. So what do you think, Jackson? How would you do this if you didn't know how to do it? It's a number times itself 4 times is 256.
Take 4 times 4 times 4.
You think it's 4?
No.
You think it's 4?
No.
He's actually right. But on your calculator, how would you check it?
4 to the 4th power.
Well, could you guess and take 4 times 4 times 4 times 4? Okay, pull out your calculators. Try that. 4 times 4 times 4 times 4. And tell me if you get 256. I think Jackson guessed and got it right. Is that correct?
Yeah.
Okay, so let's try this on our calculator again. I'm going to give you a little bigger number. I'm going to give you 1296, and that is to the 1/4 power also. So what number times itself is 4? What number times itself 4 times is 1296? Anybody got any guesses?
6.
6?
Yeah.
Is it 6?
Yeah.
All right. You guessed that pretty good. But see on our calculator how we can guess that pretty fast? And just take 6 times itself 4 times? Okay. Now, we're going to stick with the simplification. And remember, I'm going to talk about this rule right here. This rule right here. Right there. And I'm going to bring it over. And I want you to apply that rule to this. Let's try this. 64, and I showed you this yesterday, to the 2/3 power. Okay. Remember, let's talk. The bottom number, the denominator, is the root. The top number is the power. Now, I'm going to be honest with you. You can take the power underneath or you can take it on the outside. In other words, you can take, what I'm going to do is change it like Braxton said to radical form. I can take the cubed root of 64 and I can square it, or I can take the cubed root of 64 underneath, squared it. See how the square is underneath, so I would square 64 and then find the cubed root, or I would take the cubed root of 64 and square it. In my opinion, Tater, this is the better version because I get a smaller number to begin with. You understand that? So what is the cubed root of 64? What times itself 3 times, or excuse me, what times itself 3 times is 64? 4. We actually had that, didn't we, right here? Right here? Okay. So 4, and so that's 4 squared. What's 4 squared? 16.
Oh, crap.
Okay, yeah, you don't go back, right? Okay, let's try this one. All right? 36 to the 3/2 power. 36 to the 3/2 power. So, Jackson, you following this? You look a little confused. Okay? So this the bottom number is your root, Jackson. So we take that, the square root of 36. Do you understand that? We don't put a 2 there because we're lazy Americans. Do you understand that, Jackson? And then that answer to the top number, which is to the 3rd. Okay? Jackson, what is the square root of 36?
3? No.
The square root of what number times itself twice, Jackson, is 36? Jackson?
Times itself
Twice.
twice.
What number times itself twice is 36? 6. Okay, very good. All right, you okay?
Yeah.
Oh.
Just trying to
Okay. And so now, Jackson, this is 6 to the 3rd power. And I can't do that in my head, but we've actually done 6 to the 3rd power, I think, somewhere. Maybe not.
No.
Okay. So what's 6 times 6 times 6, Braxton?
216.
216. Do you understand that?
Yep.
All right? You understand that? Any questions about that? All right? Let's turn to your exercises then.
Is there a way we can find how many times the number will multiply by itself on a calculator?
Yes? Will I show you? No? Okay, not now. Not now. There'll be a day I might, but not now. Okay? And that's for your own benefit, Braxton. I'm not trying to be mean about that. It's just I want you to think about it. And
Okay.
when I find that I tell kids how to plug something in, they don't think about it. Okay? All right, let's take a look at the first set of directions. Would you read those for me? For 17, we're going to start with 17. We're going to actually do the evens, but we're going to start with a section with 17 through 24. Would you read the directions, Allie?
Write each expression in radical form, or write each radical in exponential.
Okay, if it's in radical form, we're going to put it in exponential form. If it's in exponential form, we're going to put it in radical form. For example, number 19, and I'm going to do odds because you're going to do evens, but you might want to write these down. What form is this? Exponential. So how would I write it in radical form from the beginning of the lecture? Ryan?
4 square root of k.
Thank you. And it's only the k that's underneath the square root. Does everybody understand that? Okay? Any questions? Any questions? All right. Okay, and then the next set of directions say to simplify. Let's take a look at, what I was going to do. Let's take a look at 29. Okay? The cubed root of 0.001. Okay? All right? This actually says simplify. Different set of directions. This says simplify. Okay? What number times itself is 3 times is 0.001? Does anybody want to guess? Take a guess. It's not going to hurt you. Well, what is the only number that you can get 1 times itself? 1. So it's a form of 1. Do you think it's 1 itself? 1 times 1 times 1 is 1. What about 0.1? Try 0.1. Take 0.1 times 0.1 times 0.1. Did it work?
Yep.
Okay, you're guessing, and I know he wants a method on the calculator to do that, but I don't want to give that to him. Okay, let's take a look at 39. 39. It still says simplify. You got 729 to the 5/6 power, correct? All right. All right. If Braxton was to write this in radical form, it would be the 6th root of 729 to the 5th power, right? What do you think times itself 6 times is 729? Anybody want to try that? It's 3. So I have 3 to the 5th power. Now you know how to do 3 to the 5th power, don't you? Okay, and what is 3 to the 5th power?
243.
243. So your answer is 243, okay? Any questions? All right. We have one last thing to do. On 45 through 56, it says solve each equation. Is that right? Does everybody see where I'm at? Okay. There's a rule. It's on page. It's called the power property of equality. It's called the power property of equality. Okay? And it says, if b to the x power equals...
Mr. Ellis?
Yes.
Hey, I need Allie for the rest of the day, please.
Okay.
Thanks.
If b to the x power equals b to the y power, then x equals y. Okay? Allie, you can watch the rest of this. All right? So if you have the same base, guys, if you have the same base, then these two are equal. Now, what this helps us do is solve exponential equations. I'm going to write this word out, exponential equations. And this is the last part you have to know. Okay, exponential equations are equations like this. It'll say solve. All right, I wrote that up here, and I'm sorry, I'll write it again. But you have, this is number 45 on your assignment. 3 to the x power equals 243. Okay? This is an exponential equation, Tatum, because it has a x in the exponent, right? Okay, if we can get these two so they have the same base, we can say x is equal to this one. Okay? Braxton, you with me? All right. This one has a base of 3, so can we write 243 as a base of 3? Well, I think Ryan just did that over here. 3 to the 5th power was 243, is that correct? So therefore, this can be written as 3 to the 5th power. Now, Tirsa, these two have the same base, is that correct? Therefore, x equals 5. Once you get the same base, then the exponents are equal. Now, that's all fine and dandy if it's just x. But what if you have this? 6 to the x minus 4 power equals 1296. We want to write both numbers as a power of 6, Jackson. So this is 6 to the x minus 4. It already has a power of 6. And you'll remember, Jackson, from we did this over here. I think we did this one, didn't we? Is it 720? What is it? It's 1296. Right? 1296 to the 1/4 power is 6. That's right. Correct? So this 1296 is 6 to what power? To the 4th power. Very good, Braxton. if it was to the 1/4 power. So now we have the same base, correct? And therefore, x minus 4 equals 4. Now this one's not so easy, right? Because we got to change this to plus and negative, and then we got to subtract the negative 4 from both sides. Is that correct? And we get plus a positive, so x equals what? 8. Do you see how to do that? Does everybody see how to do this? Not so easy, but you'll use these two examples to do those. So your assignment is page 414. And I'm not going to be here tomorrow, so you'll work on this. It's 18 through 78 even. Okay? 18 through 78 even. And it is due Monday. Please do not wait till Sunday night to do it because you will forget it. Work it. Try to get it done tomorrow by the end of class. You know where the book is. You can use it, but don't use the book too much. Don't use your partner too much. You have to know how to do this. Okay? It's not easy. All right. Any questions? All right. Good luck tomorrow.